So we're going to end up the semester by talking about solving quadratic equations. What is a quadratic equation? Well, it's an equation that involves x squared. So that means it's an equation that looks like or can be made to look like ax squared plus bx plus c equals 0, where the a and the b and the c stand for any real numbers. The only restriction is that a shouldn't be 0, because if it were, you wouldn't really have an x squared, and it wouldn't be a quadratic equation. So some examples of quadratic equations would include x squared minus 5x plus 4 equals 0, x squared minus 100 equals 0, and 5x squared plus 39x minus 8 equals 0. Now, we have solved quadratic equations before. Earlier in the semester, we talked about solving quadratic equations by factoring. You get everything on one side equal to 0 on the other side. You factor the side that isn't 0, and then you take each individual factor and set it equal to 0 and solve for x. So that is one of the ways of solving a quadratic equation. Trouble is, that doesn't always work. Not everything can be factored. And even sometimes when it does work, there might be another way that's easier if you're having trouble figuring out how to factor something. So there are three other methods that are commonly used for solving quadratic equations. Taking square roots, which we will talk about today. That's what this video is about. Completing the square, which we're not officially going to cover in this class, but I will maybe show you an example or two of that as a bonus topic. And then the famous quadratic formula, which we will talk about in the next section. So the main focus for right now today is solving quadratic equations by taking square roots. The key thing to know here is that when you have an equation of the form x squared equals some number, there are two possible solutions to an equation like that. One of them is where x is the square root of that number, and then there's another possibility, which is where x is the negative square root of that number. So from x squared equals some number, you get that x equals either the positive or the negative square root of that number, and those are the solutions to that equation. And here I said that the number sign stands for a positive number. Well, if you had a negative number over here, then this would still be true, but in that case, the solutions would involve the square root of a negative number, and so they would be imaginary numbers involving I. Sometimes you don't want to deal with things like that, but sometimes you do. So that is a possibility. So let's look at some examples. The equation x squared equals 81. So notice it fits the pattern, x squared equals some number. So x would be either the positive or the negative square root of 81. So what would that be? What is the square root of 81? Well, it's 9. So the two solutions here are x could equal 9 or x could equal negative 9. 9 squared would equal 81, and negative 9 squared would also equal 81. Negative 9 times a negative 9 would be a positive 81. How about this? Y squared equals 784. It doesn't really matter that the variable is y instead of x. It still works the same way. So when we have y squared equal to this number 784, that means y is the positive or negative plus or minus square root of 784. You probably don't know off the top of your head what the square root of 784 is, but if you ask your calculator, it'll tell you that it's 28. So the two solutions here are y equals 28 or y equals negative 28. Either one of those numbers times itself would give you 784. So that would be a solution to the system, a solution to the equation. How about a squared equals 13? Again, a squared, the variable squared, equals a number. So the variable a equals plus or minus the square root of that number. Now 13 is not a perfect square, so we can't say exactly what the square root of 13 is. So depending on why you're solving this and what you're planning to do with it, you would either leave the answer like this, a is the square root of 13, or a is negative square root of 13. So if you want the exact solution, that's as far as you can go with that. Or you can ask your calculator what the square root of 13 is, and it will give you a decimal approximation that goes 3.6 something, 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 something. So a is approximately 3.6 or negative 3.6. Now, those aren't the exact solutions, because 3.6 squared isn't exactly 13, it's 12.96, but that's pretty close. What about x squared minus 121 equals 0? Well, the way it is now, this is not set up as something squared on one side equal to a number on the other side. But we can get it to be that way. Just add 121 to both sides. Then it says x squared equals 121. And from here on out, it works the same way as these other examples. We go from x squared equaling a number to x equaling plus or minus the square root of that number. So x is either the positive square root of 121, which is 11, or x equals negative 11. And how about this one? X squared plus 9 equals 0. We want the squared part by itself on one side equal to a number on the other side. So I'm going to subtract 9 on both sides. And I get x squared equals negative 9. So x equals plus or minus the square root of negative 9. Now remember when we talked about what to do when you have the square root of a negative number? That's when I gets involved. If this were the square root of 9, that would just be 3. But since it's the square root of negative 9, that would be 3i. So the solutions here are x equals positive 3i or x equals negative 3i. Now in this example, it's not just x that's being squared, it's x minus 10 that's being squared. But it's still the same pattern. We have something squared equal to a number. And so the something, not just x, but x minus 10 equals plus or minus the square root of the number. So we go from something squared equal to a number to the something being equal to plus or minus the square root of that number. So of course the square root of 4 would be 2. So this means that x minus 10 equals 2 or x minus 10 equals negative 2. And then each of those is an equation that we still have to finish solving to get x by itself. So if we add 10 to both sides, here we get x equals 12, or here we get x equals 8. The negative 2 plus a 10 would be 8. So those are the two solutions. If you want to test them, look what happens when we put in 12 for x. 12 minus 10 would be 2, and 2 squared would equal 4. And look what happens when we put in 8. 8 minus 10 would be negative 2, and then negative 2 squared would be 4. How about this one? Y plus 5 squared equals 6. Again, it's this pattern of something squared equals a number. So the something, the y plus 5, equals plus or minus the square root of 6. So y equals negative 5 plus the square root of 6, or y equals negative 5 minus the square root of 6. And if you put those into a calculator, if you ask your calculator what negative 5 plus the square root of 6 is, it's approximately negative 2.55. And if you ask your calculator for negative 5 minus the square root of 6, that's approximately negative 7.45. How about this? W minus 2 squared equals negative 1. So that's the same pattern we've been seeing all along, something squared equal to some number. So the something equals plus or minus the square root of the number. W minus 2 equals plus or minus the square root of negative 1. And what is the square root of negative 1? It would be I. Square root of positive 1 would be 1. Square root of negative 1 would be 1 times I, or just I itself. That's what I stands for. It's the square root of negative 1. So W minus 2 equals I, or W minus 2 equals negative I, and then to get W by itself, add 2 to both sides. W equals 2 plus I, or W equals 2 minus I. And another way of writing that would be, you could just say W equals 2 plus or minus I. That means the same thing. It means that W could equal 2 plus I, or it could equal 2 minus I. That's the end of the part of this section that you have to know about. If you look in the book at what they have in section 11.1, they also talk about using the technique called completing the square to solve quadratic equations. That is not an official part of this class. It's not something you have to know how to do for this class. Depending on what class you take next, you might or might not have to do it there. So like if you go on to college algebra, we do talk about completing the square in college algebra. So I'm going to put up another video showing how completing the square works if you're interested, if you want to see what that looks like as a bonus topic. It's not that hard. It's just one more thing to remember. So you can stop right here, or you can go on and look at my bonus topic of completing the square.